Okay, good afternoon, everyone. Let's move on to the next talk. Welcome, Professor Rongling Wu from BIMSA. The title of his talk is The Graph Representation Theory of Statistics. Welcome, Professor Wu.
Thank you. Thank Professor Yao for organizing such a wonderful symposium. It is my great pleasure to present and share some of my research to this symposium. And the topic I will talking about is statistics. Statistics has developed to a point at which it really needs a strong theory to make a breakthrough, to better adapt to our time of big data and AI. In the past few years, my research program has been largely focused on development of new statistical theory. Let's show you what is the position of my ongoing theory in statistics. Suppose we have a statistical question, a very practical question. How the canopy leaf determine stem growth? That's a biological question, very common question. Traditional statistician may randomly collect sample the leaf with adequate number and use the individual leaf as a predictor to build up linear regression to stem growth as a response. But I think such a reductionist thinking has a significant drawback because the sum of function of individual leaf cannot present the function of whole canopy because of emergency properties occurring with the canopy. So we better understand not only how individual leaf act, but also how different leaves interact together to manipulate the stem growth. So to do so, we need to develop advanced statistics. Existing statistical model cannot consider emergency properties. So to do that, we may need to make a paradigm shift. So traditional statistics treating an event as independent happening, and different variables are correlated in a linear manner. That's the reductionist thinking dissect complexity in simplicity. But advanced statistics will treat the event as an interconnected system, nonlinear relationship occur among different variables. And we will philosophically use holistic system-oriented thinking, just integrate simplicity in complexity. So to develop such a model, so we borrow some idea from the network modeling because networks are fundamental to understanding complex system. One of my favorite research is Mark Norman at the University of Michigan. He published a lot the network works. Someone predict he may award Nobel Prize in future because of this important work. So how to construct a network? So we need a sample different variables from object like 1 to until n. Each object we may collect the representative of the attribute like variables, for example, phi, and measure the value, generate phi by n matrix data. Traditional approach actually exists the approach just using this data construct the overall correlated network. As you can see, this network has no direction. It's not good enough to capture the properties. Bayesian network has a causal, it has direction, but cannot estimate size and strength. So it's either has strong significant drawback. So we want infer from this data bidirectional sign and a waved interaction. That is fully informative. Not only that, we want to construct a network for each sample, so-called individualized network, unlike current approach, which can only construct overall network using all n samples. We have developed a generalized statistical mechanics model by combining evolutionary game theory and a predator theory. According to evolutionary game theory, two players meet together, they try to maximum their payoff by choosing best strategy in response to the strategy of the other party. So and we incorporate evolutionary game theory and pre-data theory to generate a new model. This model I call quasi-dynamic mixed ordinary differential equations. It say each player has a payoff which depends on how came from itself based on their own strategy, and also the part came from influenced by other party. So this first part we call independent payoff. Second part we call the dependent payoff. By solving these simple ordinary equations, we may have determine type of the interaction. So if these two values are both are positive, so which means two party mutualism, like being and a flower, they're beneficial from for each other. And if the negative, they may antagonism, like these two guys hate against each other. And also we can have aggressive and altruism. So but this, in other words, this simple differentiation tell you lots of information about interactions. Well, this equation quite similar in form, the LV equation. LV phase has widely used in ecological, microbiology, and engineering, and even computer science. And because this form has a beautiful mathematical properties. What is the mathematical property of our equation? Chris Griffin helped me derive a lot. He find out we have symptomatic properties of these functions. So you can safely use in different scenario. So I expect it will have widespread use as LV model does. So if we consider multiple variables, we can use metrics to solve the different equations. Supposedly, so we have data like this. So we express data in metrics like this, and we borrow the equation, expand the different equation like this. So you can see the red part is independent part. So is function f is a function of the players, each players. So on the diagonal is an independent component, and this part is a dependent part. F function is off diagonal, this part. So we use non-metric smoothly to model the independent part and the dependent part. For example, legend or diagonal polynomialism is a good approach for modeling. So we use LOP expands and with theta as a basic value at order I to present this equation in terms of non-parametric term. So we can easily solve that equation because it's additive. It becomes inductive. So by solving this function, we can construct a network. This network is called I-loop network. I do informative, dynamic, and omnidirectional, and personalized. So iDope network has now widely used in many different fields. So I list a few publications. You can use the cancer biology, microbiology, gut microbiome, and the plant science, and so on and so forth. So we will see the wide spread use. To construct a complex network, we meet 5 parameters. First of all is causality. Causality is has been solved by that different equations, right? And next, 4 parameters need to considered. So we have make a transformation from the different equation to multiple regression. So like this, that is nonlinear fitting. I'm sorry, it's a non-parametric fitting. And by integral of this, and you will find out like this. So this form unchanged in terms of the basis values. So by solve this equation, so we can incorporate a linear regression model. So ordinary differential equation is very complex, is nonlinear. But after this transformation, we got multiple nonlinear additive regression model like this. So all study will based on this model, which make our life much easier. So how to construct a high dimensional network? So we can class all elements into different modules, and we construct the network among the module, and conduct network within module like this. So 20 years ago, I developed a model called functional clustering. This model has been widely used in statistical modeling of longitudinal data. One of the students, Zoe, with us several days ago, he helped me develop this model, published in top statistical journal, JASA. And this work has been highlighted by Nature Review Genetics, select one of 22% best papers in entire biological and medical field. And I introduced this work to my current institute, BIMSA. Several students of my lab, Dong An, Wenqi, Pan Wenqi, develop improved algorithm for functional mapping, which I'm very happy about that. So make this approach more useful in broad scope of field. And so we incorporate multi-test learning to infer sparse network. So this network, so we want to select the most significant part to each response. So we incorporate multi-learning. This work has been developed by one postdoc, Zifang Li in BIMSA. So the works very well. How to construct stable network? So we construct network under mixed likelihood setting. Likelihood is what kind of optimization technology. Under this setting, the estimate will naturally become stable. So we will several of us will publish the paper. Almost done this paper. So at the end, so we will construct a multi-layer, multiplex, multi-space, and multifunctional network with castle, stable, and sparse, like this. So in the top tier, so we may have the network among community, and we can project all network into the surface. So you can see any one node have a significant influence flow to next through the way you can find out. So all these record the interaction pattern among any variables. we perform statistical simulation to test the statistical parameters of our IDOM network. So we assume simulate the 20 node the network with the curve like this, and find out the true positive rate and false positives all are better than current approach. So you can see this. And I will focus my time on the experimental validation and application. So the application will have three fields. The first one, so I want to use IDOM network to start the IBD. IBD is a popular disease with unknown mechanism. It includes two types, UC and CD. Each affect our gut differently. So microbiome in gut may be a cause of IBD. So by collaboration with Professor He Huang at the Tianjin University, we collect about 134 bacterial species in 46 UC, 20 CD, and 25 health control HC. And our question is how micro interaction distinguish among these three groups. So by using three variant functional clustering, so we construct the network among 10 modules, 11 modules. It's interesting to find out in health control, M1 is a hub, but in UC and CD, MC are hubs, become a hub, just a center in the center. So this asks us, is there any special micro species within these hubs? So next, so we construct the network within each of these modules, just like this. The is small, but it's hard to see, but you can identify key difference before among these groups. We do some functional validation, choose the wild type mice and immunological weak mice, so knockdown mice. These two mice will be inject the module 3. This work is will conducted by PhD students Jia Nanyi at Tianjin University. He is a visiting student at BIMSA. So let's look at this graph. You will see the HC has a M1 as a hub. The UC and CD has M3 as a hub. So we insert the micro from M3 into the mice, and see what's happening. What happened in those mice? It turns out after injecting the module 3 and module 3 hubs, we find some significant change in physiological capacity. So this panel demonstrate the immunologically weak mice has significantly reduced, but the normal mice has generally unchanged, and all these very consistent. So which suggests in immunological mice, the M3 has a lot to do. M3 may a cause for IBD. So we further test the analytically change. So all these figures demonstrate support the finding from physiological capacity. So let's show you some interesting figures, like this one. So you can see this one is has a strong problem because it receive the M3 module, but the normal and Y type is similar normal. So this suggests that M3 is very is a key module which cause IBD. So this model has been used in other field, like how to map the electrocardiogram. So the electrocardiogram has 3 types of leads in the chest. So you can see the 6 ways from the chest, and lip leads like 1, 2, 3, and augment lip leads. So you will see those the traditional approach try to see what does the lead change from health to disease status, but they do not consider the interaction among these leads. So we hypothesis, we have hypothesis, which is interaction among different leads are associated with a rare miss. So this data, how we collect? So you lie down the bed, so you will get 12 different leads in this data. Data analyzed by Yuan. So we do find some interesting things. So in this is a myocardial infarctions. So we find out AVF is a center, is a hub. So inhabited by many other leads. But in the normal heart, so things are very different. So only we find lead 2 is a hub. So this finding is very consistent to medical observation. For example, this one inhabited by many different very different leads is consistent to fact that AVF is a confluent point of electricity activity for MI. So this very well support medical observation. Model has been also used to construct a gene regulatory network for malaria infection. As you all know, malaria is a life-threatening disease for humans caused by single cell parasites. So this bite humans. So the parasites will go through that life circle in human body. So we select a few key stage, and see how gene interact with each other to determine this life circle. So we in this example, so we collect ring here and this one, and these 3 stages, construct a network for each stages. It is find out. So the genetic architecture of the gene interaction differ among these 3 stages, and we identify key genes which manipulate the malaria infection by interact with other gene. So by this general conclusion, so identify specific gene interaction, determine pattern of parasite's life cycle during malaria infection. So by manipulate some genes, so we can promote all the silence some gene interaction to treat the malaria infection. So genetic information will provide you useful tool to treat this disease, control this disease. Statistical contribution of IDOB network. So it can be alternative to linear regression model, right? So current statistical model is linear. So we can consider nonlinear We not only consider estimate regulation correlation, we also estimate causality. So we can direction of correlation. So we can analyze unregular data, unlike many different models which can only analyze regular data. For example, this is irregular data. So you can see data is very sparse and sample size is small. A traditional project, for example, ANOVA t-test cannot work. But use our model, we can nicely construct the network among this spatial change of network across a long gap. And this project could be a replacement to PCA. As you'll see, PCA has widely used in statistics in other field. But the PCA has a significant limitation, which is information loss. So which cannot capture all information. And also the transformation is based on linear linear pattern. Is variable may change in nonlinear way. So PCA cannot chart full picture of bidirectional sign and wave interaction among variables. Our model overcome the limitation the PCA may have. And it's very flexible also for variable selection. So we can use a small sample size to construct network, unlike many different projects, which are based on huge number size. In practice, it's very difficult to collect huge sample size. More importantly, our model may alleviate statistics from tool to science. In the past, statistics has widely considered as a tool to help other people to analyze data, not just it. But now, statistics could be science itself. So we can address scientific question by ourselves. So by using IDOM network, we can get this goal. If we make a cross-pollinate to mathematics and AI, I think we may revolutionize statistics. At least a few areas we want to make a cross-pollination. If IDOM network meet Perl-Yau's topology, so we may produce topological statistics. That is one new field. So Perl-Yau and a team develop a topological model to study topological feature of a diagram. My colleague, Professor Jie Wu, told me a lot about Perl-Yau's topological theory, and I'm highly appreciative for his help. I learned a great deal from him about topological theory. And we use Professor Yau's topological theory to study the GART IBD. So we collect data from IBD database by Stanford University. We got 155 metabiolotes measured in health control and 2 types of disease. So we do find that network significantly different. So as you see, this one, health, M8 is a hub, but CD and UC is M3 hub. So you can see the network is more complicated in disease than in control, based on the topological dissection. So here is topological feature at 1-dimensional and 2-dimensional and 0-dimensional. All these indicated some interesting finding. I just summarize the finding in this graph. We do find in health control, this guy, linear net, has nothing connect with other the metabyte. But this one will promote this guy, M acetic acid. This guy is promote histamine. Histamine can inhibit IBD. So in health control, this pathway is very well connected. Is very well connected. But in the UC and CD, all this inhibit the formation of linear lead. So if linear lead is inhibited, this pathway is blocked. This pathway is blocked. This high is blocked. So he got disease, got IB disease. So interesting to see these two disease type control with different architecture. So topologically are different. So this finding can provide guides, scientific guides on anti-IBD drugs. I talked this finding with many different doctors. All recognize this interesting finding and can potentially transformed by pharmacon. And I do never can meet the node theory become no statistics. So as our early study, we have data from Amish people. So as you see, Amish people is the ideal material of genetic study because they have quite a genetic uniform and they live in quite a uniform environment. Is a very good material for genetic study. So we collect the microbiome from the gut and find out the high order interaction network. You can see. So these two microbiome connect to each other, but the connection, the age, determine the abundance of third microbiome. So this kind of interaction called high order interaction. So in node theory, I would think this one could be like a node, right? Happy node. This node is not physical exist, but it virtually exists. So we can incorporate the information theory by into the node theory, find out from this very complex network to find the very useful node units. With these node units, we can better interpret how these microbes interact to determine the human health. And we can genetically, biologically manipulate the microbe. In other words, we can create a new group of microbe which can beneficial to human health. So this I see that node theory will be very much useful by incorporating statistics, make statistics more useful in broad area of the field. iDope network can integrate with a Yao filter. Professor Yao and his younger brother joint direct Yao filter. So which is go beyond traditional common filter, which is linear. So Yao filter can solve nonlinearity, uncertainty, and noise, and incorporate iDope network, we can construct the Yao stochastic network. This small video, let's show you. Okay. You can see each you can see the age vertebrate is not stable, is perturbate. So the perturbate due to the perturbation. So other model cannot identify this, but incorporate the Yao filter, we can identify how each age perturbate around that time. And this second one, you can see. So not only the age part of it, but not part as well. So this joint work by my students Su Xue and Wang Yu, and we can expand iDope to high order interaction, produce mechanical statistics. Just keep in mind, it's not a statistical mechanics. Statistical mechanics is a very different field. It's a kind of mathematics. But here, so we may produce mechanical statistics. So in the world, the high order interaction is quite universal. So just like one habit two, but four habit the connection between one and four. So we have one order hyper and a two order hyper graph. So these two publications in top journal Nature and Physics both demonstrate the importance of high order interaction. So we also have developed a general statistical model for mapping and estimate the complete picture of working at a different order of interaction. So this general statistical model we developed. Model have been used to analyze real-world data published in Science. So there are 6 micro species, and use our model to analyze how these micro species interact to each other in pairwise and high order interaction. So we do find the high order interaction exists in this small community. They published last year in PNAS. iDope network can meet graph neural network with intelligent statistics. So this general picture for deep neural network. So input right here. So go through different layer of neural network. You will got the output is classification or prediction. So we incorporate my colleague Professor Yeqian Wang. And we incorporate iDope into graph neural network to study how micro interaction determine the quality of Chinese liquid. So if you choose the traditional approach, so they make the combination of microbe, so you may produce the liquid like this. But if you use the communication of the micro from our model, so you will increase the liquid quality by 10 to 15%. I think this is a significant increase. So next, we collaborate with our collaborator to do experimental validation. If the experimental validation successful, support our conclusion, I think this is significant advance in statistical study. Conclude, I use that diagram to show how statistics develop through over centuries. So in 17th century, there some pioneer researcher proposed critical concept of statistics, like Bernoulli trial, Bayesian law, and Gauss distribution. Gauss popularized the distribution of data, and in the statistics has a significant development in this time period in the early 20th centuries. Here, the number of well-known statisticians come out. The proposed Pearson correlation, linear regression, chi-square test, hypothesis test, ANOVA, and Mixon likelihood. The ANOVA Mixon proposed by R.I. Fish, who is my favorite statistician. I respect her a lot. He pioneered a lot of concepts in statistics. In the 20th century, so the most statistical work actually all based on their work in this time, developed in this time. In other words, later 20th centuries, have not significant breakthrough in statistics. They develop some mixture model, longitudinal analysis, EM algorithm, MCMC, high dimensional analysis. All this, I think, is largely rely on early work. So there are no significant breakthrough during this period. So to 21st century, the statisticians become more worried about the future because the AI and the big data came out. So big AI, either big AI replace statistics. So most statisticians worry about this question, worry about the future. So I think they normal, they worry because they do not consider the deeply think about how statistics develop in the future. They only possibly learn deep learning, possibly integrate AI, but nothing about their own work. So, but in my opinion, I think we may develop a different way to advance statistics. So here, this part is my academic trajectory. Before 20th century, I'm a field biologist and I do ANOVA. I do quantitative genetics. And after enter the 20th century, I'm become statistic geneticist and propose functional mapping, functional cluster, and all the algorithm and pharmacogenetics. This part has been making me have a good position in biostatistics. And we also do this part. I also develop the system mapping, network mapping, and combine evolutionary game theory, and I do the network. Until 2021, I have first seminar to the YMSC. That's my hallmark in my career. After that, years later, I joined the BIMSA. In the last 3 years, I learned a lot of mathematics, mostly by Professor Yao. Topology, Yao filter, computational conformal geometry, high network, and graph and neural network. I think it's time combine this development to generate a new theory, the graph representation theory of statistics. So look at my academic trajectory. I came from field biologist to the applied statistician. I'm very happy I will become applied mathematician since I joined Professor Yao's group. Our theory will be systematically used in a book. I got an invitation from the editor of Elsewhere. So we will contribute a book, summarize the new statistical theory developed. I decide the book cover. So Dr. Doan and Professor Yao and me will join to complete this book. So it's on time schedule. I think we can complete next year. Yao Institute across many different institutes will be leading center for developing advanced theory of statistics, promote the development of next generation artificial intelligence. Why I say that? Because we have a number of excellent mathematicians. So I didn't see any place that like us. So statistician can work closely with applied statistics, with mathematicians. In the United States, the statistician generally independent from mathematician. So it's time now to borrow mathematician the idea to statistics to promote statistics. Otherwise, we will better end, I think. So that's why many statisticians worry about. So I thank for my institute give me such a good opportunity to do good quality research. I especially thank Professor Yao for teaching me mathematics. So in the weekend, Professor Yao teaching me some very new mathematics to me, and I recognize 学习数学很苦。 但是键词很酷。好，Thank you。
Thanks for Professor Wu's